Hello, everyone. Welcome to the very first Performance Summit London edition. I'm super excited to kick off the event. This is the first in a series that is conducted from London, and it's going to be influenced by London vibrant community around research and financial sector. So we are going to have amazing talks covering low latency and research that is happening, that is pushing the boundaries of what's possible in performance space. There's going to be some AI, there's going to be some exciting low-level tech. So I'm super excited to kick off this event. Just quickly about the logistics, what's going to happen is that I hope by now you had a chance to join our Slack channel. The entry point should be the Perf Summit London edition channel. That's where I'm going to be posting the channels dedicated for each talk. So during the talk, whenever you have questions, please post them in the dedicated channel so that speakers can see them. And also, if we have time after the talk, I'm going to ask those questions to our speaker, and speaker will have a chance to answer them live. If we run out of time, then speakers will be able to still continue the discussion and answering your questions even after the talk is over. We also hope to upload all the recordings to our YouTube channel, which, again, hopefully you have discovered by now. But if not, you can always find details on our event page or Twitter account. We have a dedicated Performance Summit Twitter account, and hopefully you'll be able to discover all the content that you're interested in. And that's, I guess, pretty much it in terms of logistics. I hope you're gonna enjoy the event, and please don't miss the opportunity to ask any questions you have to our amazing speakers. To start the event, we are gonna have Fernando from Amazon, who's going to talk about Amazon CodeGuru, which is an exciting mix of research and practical development that allows us to profile, understand, and make useful suggestions in terms of performance optimizations. So without further ado, let's start with the first talk. Fernando?
Thank you, Taras. Hello, everyone. Thank you for joining us in this talk. I'm Fernando from Amazon Web Services, and I'm here today to talk about Amazon CodeGuru Profiler, a software profiling service launched by AWS last December during reInvent in public preview. So the profiler is now generally available, meaning that it's now fully supported by AWS. So let's get started. So what we'll talk about today. Because the audience may have different levels of familiarity with the idea of software profiling, we are going to start with a very short introduction to software profiling. What is profiling and why profile? And we will speak later briefly about how people typically do profiling with conventional tools. And you understand why profiling is not so popular yet. Then we'll talk about Amazon CodeGuru Profiler, of course. That's why we are here, to show you how we can make Profiler accessible to everyone, and that is one of our goals. And finally, we reserve a few minutes at the end for a Q&A session. So, software profiling. What is profiling? Why do I need it? We'll start working backwards, so let's have a look at some of the customer needs that usually end up with profiling being a solution for. So these are actual customer testimonials, cases that we receive at AWS Several of them I will share here with you so that you have an understanding of how our product may fit your reality. So the service had been completely down for 38 minutes. Restarts were not helping. There hadn't been any deployments in the previous 3 weeks. We tried to roll back the software to a previous version anyway, no success. Someone in the team reminded me that we had onboarded the profiler from AWS just a few days earlier. We went to the AWS console, opened the flame graph for the first time, and voila, the answer was there, staring at us. A rarely used code path had been triggered by a recent request and was causing a global system lock due to an unhandled exception, which had been muted. That's why nothing relevant was showing up in the logs. In just over 4 minutes, we had an emergency fix released and the service was up again. Lucky them, they had the profiler. If I remember well, they were starting to evaluate the profiler those days. They just got it in, but they hadn't really spent any time trying to understand that because they were in a hot season, working hard, and they left the profiler there just sitting aside, collecting data about their application, and was exactly the profiler that helped them to get out of the situation. So, lesson learned. You can use a profiling to troubleshoot issues affecting your services, even issues in production. Customer case number 2. And then came the lockdown, and people staying at home figured out that this was a great time for online learning. Yes, all of us. Boom, our traffic grew 5 times in a matter of days. We were cloud native and well architected, so scaling up our AWS infrastructure to meet the needs of our users was really simple. So those are great news. The people had done their homework and being ready for significant traffic increases. So we are now looking at this massive number of virtual servers and instances we have running and cannot stop thinking, do you really need all these machines? Are we making the best use of them? Are there any low-hanging fruits out there in terms of software improvement that could help us reduce the cost of our infrastructure and its size? Customer case 3. With the profiler, we identified a simple software fix. Our North America fleet was reduced from 56 hosts to 8 hosts. Garbage collection efforts dropped from 39 to under 1% CPU. P50 API latencies dropped from 39 to 26 milliseconds, P90 from 158 to 34 milliseconds, and P99 from 554 milliseconds to under 100 milliseconds. Well, gains in all fronts. So reduced infrastructure massively from 56 hosts to 8 hosts, reducing garbage collection, so reducing inefficiencies and focusing CPU usage on what it matters. That's handling your business cases, your business application. And improved in P50s indicates that, okay, the system is responding faster in average, and from 39 to 26 milliseconds. So it's a massive reduction in latencies, a massive improvement in response times, and lower P90 and P99. You see, it's a more stable application, an application that's more reliable under multiple load conditions, and you won't end up with customers being penalized, some customers being penalized with very high latencies or very slow responses. Several optimizations using the profiler resulted in increase of service capacity from 85 to 250 transactions per second, with no additional servers, and an average reduction of latency in all APIs worldwide by 40-50%. After a few optimizations with the profiler, our service was able to serve 122% more requests for this year's online event, while using less than 2/3 of the hosts we needed last year. Customer case 4, the last one. As part of our shift to the cloud, we need to start moving Service X to AWS as soon as possible. This is our most important mission-critical system. It's a complex monolith with lots of obsolete code paths. We need a way to find out what parts of the code base are actually in use, which ones are the most relevant, and prioritize the reporting to the cloud to better architectures like microservices or even serverless. So again, we see this all the time, profiling for gaining a better understanding of your software, how it's behaving in production, to see what are the code paths that are being used, what are the parts of the code that are being used the most, so that you can focus on porting those, optimizing those, modernizing those, or extracting them from your monoliths first, building microservices for those cases, and in this case to get them to the cloud, but could be even an internal application improvement effort. So profiling and profiler to help. And what do all these cases have in common? So the challenge that they had there was that they really needed more data about their applications, runtime data. So dynamic analysis of their application. This is what they needed, because this information was not in their logs or metrics. They hadn't predicted that they would need this sort of data. And it was hard or impossible to figure out these insights, this data, just looking at the source code. They also needed recent data about what was happening in a timely fashion, because they couldn't wait longer to get this data in some case, like that one, the case one, when they were troubleshooting an issue in production. And they really, as I mentioned, they wanted to see the behavior of their software under real workloads. And so profiling to the rescue. So I hope I have increased your appetite for profiling. It's just a starter though. But so finally, yes, what do we understand as software profiling? It's basically a way for you to collect, process, and analyze granular runtime data about your software or service, and collecting data that you hadn't predicted that you would need. So you hadn't invested on adding logging or metrics to track that dimension of your software, of its runtime behavior. And with a profiler, you collect this data post factum as you need. So why isn't profiling more popular? So a typical profiling journey with a profiling tool usually involves selecting a profiler that suits that environment specifically and your needs, but sometimes you don't even know what you need if you're getting started. And integrate your application with that profiler. Sometimes it requires significant changes to your application, introducing specific calls, instrumentation, so that data can be sent to the profiler. Then you need to execute the data collection process in your servers, and if you are profiling production, so this means your production servers, or you could be profiling on your dev environments, your dev desktop. But most profiling tools introduce considerable overhead, and they are prohibitive for usage in production. If you try to profile there, your application is probably going to slow down or stop, or it's going to change the characteristics of your application. So if without a profiler your code's behaving some way, if you add a profiler and it takes too many resources and competes with your application, you are not going to see the reality of your application. You are going to see a distorted reality of your application, trying to see it on the and operate on the resources that remained after the profiler took its own share to operate. So it's not good at all when a profiling tool needs a lot of resource itself. Then with those tools you end up deciding, okay, let me profile in a dev time or in a dev environment. But then you need to, if you want to have an accurate picture, to recreate the production traffic in your test environment, so that you can mimic real traffic and understand really what your software would be doing in the real life. Also a hard problem, and requires a lot of effort. And if you pass through those, then you need to get that data that the profiler collected somewhere to be processed and aggregated for analysis. Render that data in some way you can try to make sense of it. Could be a report or a graph, and make sense of it. takes time as well to interpret an output of a profiler and seeing what can you translate into actions and improvements. And if you need more analysis because maybe you didn't capture exactly what you needed, then you go back to step 3, rinse, repeat. Profiling should be simpler. Absolutely. What if you could have a low-cost, low-overhead profiler, easy to connect to your services, that does all the heavy lifting of data collection, transfer, aggregation, and cleansing for you, and you can use it to watch your systems in production, and you can do it continuously, all the time. And still, a profiler that can help you understand the profiles that you're obtaining from applications, can provide you automated analysis of your application and actionable insights for optimization. Yes, so not stopping only at the throwing the data, the reports at you, but also trying to give you an understanding of that data, provide you some insights. Yes, it exists, and this is called Amazon CodeGuru Profiler. And let's do some smart profiling with it here. So one of our objectives is to make profiling available to everyone. And so that's why I launched CodeGuru Profiler. It started with JVM support, so for all the languages that run as JVM, Java, Scala, Python, and so on. And more languages and runtimes are coming very soon. It also runs on multiple platforms. You can run it on premises or in the cloud. Any OS where the JVM runs, it can be run, so no limitations there. And if you're on AWS, so yes, obviously, if your application is running on EC2, Lambda, ECS, Fargate, Beanstalk, you can use the profiler to investigate them and optimize them. Also, profiling made simple, so easy to onboard. We don't want to be on your way when you need the profiler the most. We want you to get the tool, get the service, connect it to your applications, and start seeing the results straight away. And that's why we offer 2 options to onboard: a standalone agent that you invoke using a command line in the initialization of your JVM, passing the option -Java agent to it, and then it will start the profiler alongside your application, the JVM, and ship the results, ship the data to AWS, to the backend service. And there's also an option of a minimal agent running as a library to integrate with your build pipeline, so it can make easier for you to manage dependencies and customize how you want the agent integrated with your application. We also want the profiler easy to use and maintain, so you start by finding it in the AWS console. Simple like that. Go to the AWS console, to the service page, and just type profiler, do a search, and you should get to Amazon CodeGuru Profiler. So it's there on the AWS console that you're familiar with if you have been using AWS. If you're not, create an account, get started. You have guidance all around the place, and there are 2 demo applications for you to play with there and understand the profiler. We are also, as I mentioned before, focused on providing continuous profiling. And why profiling all the time, you might ask? And we ask, why not? So, profiling all the time because systems do not fail on the schedule. That's an obvious one. Because we are offering you a profiling as a service, not as a standalone tool. So we are taking care of all that heavy lifting, all that pipeline for you. It's always there 24/7, 365. We are offering this convenience, and you can have the history of your profiles preserved. So you can go back to them to troubleshoot recent or past service issues, do root cause analysis, for example. And for analysis of variation of your profiles across time and learning of the characteristics of your software when running under real workloads. So convenience, yes, here is an example of how you see the list of profiles. We call them profiling groups. We didn't want to call them applications. We didn't want to call them anything more contextualized. We left the name quite generic. Profiling group is a place where you store profiles for whatever you want, for your application, for your microservice, for your auto-scaling group. You choose the semantics that you want for the profile, and you create a profiling group and associate with that representation, that semantic. So here we can see in the console 5 profiling groups in my account. 2 of them are the demo profiling groups that I mentioned to you, and the other 3 are the profiling groups that I created to test our agent with Solar, Tomcat, Wildfly. 2 of them are actively profiling from those 3 I created. 1 is inactive. I switched it off because I've temporarily switched off that server. And yes, it's here for you anytime, all the time. Just go back and see your profile when you need. And what happens when you click on one of those profiling group links and get into the profile visualization itself? Yes, we offer advanced visualizations, flame graphs. Flame graphs look like this. You may have heard of it. Hopefully you have. It's becoming the standard visualization representation for profiles all around. It was created and popularized by Brandon Gregg from Netflix. And for those who haven't seen a flame graph before, it might look a bit scary. There's no reason for that. Flame graph is extremely simple to understand, much simpler when you get used to it than trying to figure out how an application looks like, looking at, for example, collapse and expand hierarchy trees. This is you have all the information you need in a single visualization. And we have other interesting visualizations. We have hotspots. That's a flame graph upside down, where instead of starting from the parent and going through their children, we start from the children themselves. So which are the methods that are taking most of your CPU time, and then we analyze going down these icicles, which are their parents, who are their parents, the methods that have been calling them. And we also have middle out or inspect. When you combine those 2 visualizations, you pick a frame of interest and you can see all its children and all its parents in a single visualization. And we'll allow you to inspect CPU and also to investigate latencies if you prefer. So latencies or wall clock time. So you can select the mode of investigation that you have, CPU latency, or even a custom method here for Java. In the latency view, then if you're in the latency mode, your frames, the width of your frames represent really wall clock time. It's an estimation. We don't do tracing, so the profiler does not try to capture exactly the start and stop time and the duration of each method invocation you have. Otherwise, it would be extremely expensive computationally to be doing that. And yes, we show cost estimations per method as I mentioned before, and that's really helpful for many of our customers to realize the importance of optimizing a specific part of their code and reducing their compute costs. But finally, maybe the most compelling and interesting reason for using a profiler like ours, or one of the most compelling, is the sort of analysis that our profiler can be constantly making about your application and providing insights on those. So you may have noticed here that there was a recommendations button there on the top with a number 4 attached to it. Clicking that button, you drop into the recommendations panel or the recommendations report. So it's a report that contains 4 recommendations for you here. We'll scroll down a bit to see details of this recommendation. So the system is found out that we are doing here in this case too many recreations of AWS SDK service clients. We're spending 18%, over 18% of our time, of our CPU effort doing this. while we could be reusing them everywhere, typically through dependency injection or caching, as we are recommending here. And here is there are links to the stacks, to the call stacks that contain where we found this usage, and that you should look at and try to improve and move this maybe to a desinitialization to a static or singleton or something like this, so that you don't really reinitialize this. It's reusable. What else we have here? Have you got here? Another finding on the same application: repeated Jackson object mapper creation. Again, recreation of something unnecessarily that could have been initialized once and reused. And yes, Jackson object mappers are thread safe and expensive to create, so create only one wherever possible. And so these are the insights that, yes, you get from the profiler all the time. There are plenty of them. And yes, we don't have much time here. I have to try to shorten this. In addition to those sort of insights, we also offer anomaly detection. It's a new feature launched just now at GA, where we observe the history of your profiling, and we can highlight, okay, there has been a significant change to this or that method. Please have a look at this profile because there is something at least different, if not strange, going on here. So you can get this sort of insights from the profiler. And we take so seriously the profiling production that we have invested a lot into lowering the overhead of our agent to the minimal possible, so the agent only reports data back to the profiler in wider intervals. It collects data often, keeps them on the host, and only ships back to the profiler when there's a good opportunity for that, so that doesn't impact your application. And we also manage the scale of profiling dynamically and constantly, so agents are always heart beating to the profiler. And if we don't need all of them collecting data, we tell them, okay, stop, go to standby, wait, when we need, we call you back, or they call us back, in fact, to check if they should continue working from time to time. And also we understand that in production you may have a need to stop profiling if you are afraid of something like, let's say, an overhead that you don't understand or an instability. And if you want to have this peace of mind that the profiler is not there in your way, you can stop it remotely. Agents remove themselves from processing, and then, yes, you have the profiler totally shut down across your whole fleet just with a click. So the fact that the profiler is in AWS also, so then you get together with that a lot of the benefits of being or using an AWS service. So low cost, you only pay for what you use. It's secure, authenticates using IAM. You can use tags to implement your own granular access controls. You can track usage of the profiler with CloudTrail. You can model and deploy the profiler, at least the server side, defining the profiling groups, permissions, tagging, so on, with CloudFormation. You have available to you APIs and SDKs for integration and extension, so it's part of the AWS SDK. AWS support to get help when you need, and documentation, and a global presence. The service is available in 10 regions now, but you can profile from anywhere. Just configure your agent to report to the nearest available region, and you are set. Let's move to the Q&A, and thank you so much for joining us today. Happy profiling.
Awesome. Thank you, Fernando, for the amazing talk. It's exciting to see all these efforts happening it's great when performance just happens by magic and we don't have to do anything. So I'm very much looking forward to see even more functionality available like that. So we have just a little bit of time for the answering questions. So as a reminder, please direct all the questions to the Slack channel instead of the Q&A section of the BlueJeans, so that we always have them available even after the talk is over. We'll still be able to direct them from our YouTube channel. So the first question is from Arun is, how does CodeGuru compare with AWS X-Ray? Fernando?
Hello, Taras. Hello, everyone. Thanks for joining us this morning here in London. Yes, it's. I've been trying to type and answer this on Slack in parallel. I really wanted to watch my own presentation, so I was very focused on the presentation. Sorry for the delay answering that there. So X-Ray is very focused on tracing. Is when you want really to focus on the life cycle of a request. You want to. Your application receives a request, and you want to break that the time that takes to process that request down to at least to see a breakdown per major component. So you spend some time receiving the request and then doing some authentication, maybe you're using a Lambda for that, and then doing the processing to address that request itself, then preparing a response back. And you might have several services. You may access a database and retrieve data for that request. So you have a conjunction usually of services to serve that request, and X-Ray is great at that. It's showing you a breakdown per service, subservice boundary, or how much time you spend in each one of them. While the profiler helps you to dive deep into your processing nodes in that case. So let's say you start processing a request. One of the steps is, okay, send this to my application server that's running on EC2 to prepare an answer. And then you don't see from X-Ray anything about what's happening inside that EC2 box, inside your application server. So the profiler helps you exactly there. You go to a profile and you see, okay, how is the application server spending time? Where is it spending CPU to process that request and respond back? So they are complementary services. X-Ray, it's a tracing solution. The profiler is what we call a profiling solution, the name says, where X-Ray is very focused on figuring out the accurate timing for the steps processing request, and the profiler that helps you optimize overall your process infrastructure.
Thank you, Fernando. So the other question is, actually we are almost out of time, but Jay asked, hi, looking at this profiler's functionalities, does that mean we don't need any APM tool like Dynatrace or New Relic to use?
Yeah, we see APM as collections of tools that and services that help the system administrators, operators, or developers to have a consolidated view of a more complex scenario. And usually APMs allow you to plug additional tools to them to have a single pane of glass, a single place to see where things are happening. The profiler can be used together with your APM of choice. The profiler is an additional tool that you can have in your toolkit for that scenario of investigating application performances, and you can correlate what you see in the profiler with metrics that you get from your favorite APM or from CloudWatch if you're in AWS. And yes, there's no conflict there. Some APM tools, they offer their own profilers with their own propositions and they can add value from different perspectives as well. But yes, there's no idea of replacement. If you are happy with the CodeGuru profiler only and don't need other profilers, you still can use other parts of your APM solution for for the other areas that they usually cover.
Perfect. And last question, just real quick, from Arun. How does CodeGuru tackle the typical problem of too much overhead versus high visibility into all transactions?
Great question. So our proposition is to be, as you have seen from our presentation, it should be a profiler that is continuously on low overhead in production. And for that, we work with an idea of approximations. So we are a sampling profiler. We have a sampling profiler. We collect snapshots of the reality frequently, and then we aggregate them. And the aggregate converges to your reality. So you're not tracing every request. We are dynamically adapting the load of the profiler on your fleet to minimize overheads. So our agents are constantly checking with our service. Do we need more data to give more accuracy to our users now? Is there opportunity in the server to do this? So let's collect more data. Or no, the service is getting busy. So step back, lower down, and we show to customers. It's totally transparent when you're looking at profiles on the CodeGuru Profiler console. We are already selecting for you a window of profiling that has enough statistical significance so you see an accurate picture. But all this is done in the behind the scenes for you, so you don't need to worry about these trade-offs yourself.
Well, that sounds awesome. That's actually exactly what I was expecting, and that's great that that's what's happening. I didn't expect anything else from Amazon. This is really good stuff. Well, thank you so much again, Fernando. Since we are out of time, we're going to just make a very small break, like 1 minute break, and we are going to continue with Arun's talk about benchmarking. Thank you so much again, Fernando.
Thank you, Taras. Thanks, Facebook, for organizing this.